Hello. Hello. Welcome to another session of Math. Today in this video we'll be looking at how to solve this problem here with DI method and substitution approach. Integral x multiplied by tangent inverse of square root of x dx is an integration apart question. And with that, either we use the traditional approach or the DI method. But before we apply the DI method in solving this one, we see that tangent inverse of x, tangent inverse is what? Square root of x rather than what? X. And this is, you could have just, apply the DI method right away and then we just know what we are going to get at the end of the day. But this is where the problem lies. The square root of what? X, tangent inverse, and this square root of x. It's not x, whereby we know what we are going to get at the end of the day. But here is square root of x. Well, because of this square root of x is telling us, well, we are going to take away this square root of x with the substitution approach. And when we do that, that one will not when we take the derivative of this, it will not take away this. It is rather going to increase this particular problem. But no matter how it got increased or it get increased, it won't be a problem at all because we can easily work on it. So now that we know the approach that is going to be used, why don't we get started? But first, let's write our solution. And then let's bring this integral down here. Yeah, x tangent inverse of square root of x dx. Yeah, I said we are going to use the substitution approach to take away the square root of x. When the square root of x is there, it scares some of us. You can apply the DI method, but when you choose to differentiate this one, you will not only differentiate the tangent alone, but you differentiate the tangent inverse of square root of x, which at the end of the day, this square root of x is also going to be flatted. It's also going to be what? Differentiated. So to make it simple, why don't we take away this square root of x with the substitution approach, and then so that we can easily, when we apply the DI method, we can easily either integrate or differentiate what the tangent inverse of whatever is going to be replaced here or going to be put here. Okay, so substitution. We are going to let u be equal to square root of x. Now let's square both sides before we differentiate. Let's square both sides. Now u squared is equal to x. Now let's differentiate. And when you differentiate this, you are going to get 2u du, and this one as usual will give us what? Dx. Okay, 2u du is equal to dx. Okay, we have gotten something that is going to replace what? Square root of x, but initially we didn't know after replacing square root of x with u what is going to replace what? dx, and now we have gotten that one also. Dx is equal to 2u du. So when we go back to the integral question, where ds is, we just put this one there, and where um square root of x is, we just put u there, and where we see x, what are we going to put there? That is u squared, u squared. So let's put them into the integral. Good. U squared multiplied by tangent inverse of u times 2u du. Now you could see that this place is not scary anymore. It's like the normal thing that we know. Tangent inverse of x, tangent inverse of y. So when you differentiate, we can easily write our answers compared to the other one. Now let's multiply this. This 2 here is constant. We can bring it outside here, and then u times u squared will give us what? U raised to the power 3. U raised to the power 3. So this integral here is going to give us integral u raised to the power 3 times tangent inverse of u. Okay, now there is our we have gotten our normal integration apart question. So here we can apply the traditional approach or the DI method, but as I said, I'm going to use the DI method. Okay, so with the DI method, I've already told you, you differentiate one, you integrate one. It's like the normal traditional approach that we normally use in solving questions of this nature. So here I'm going to differentiate tangent inverse of u, because integrating tangent inverse of u won't be all that easy for us. That one also requires, another thing on its own. So to be on the safer side, let's differentiate this one, and then we integrate this one so that we can easily write answer for each of them, after which we multiply whatever we get, or we find out if we can get 0, or if the product of a row can be repeated in order to be added to this one. Okay, but mind you, when you apply the DI method and you are writing your answers, make sure whatever you pen down at the end of the day, you multiply it with this constant here. Okay, because it's this whole thing that we are integrate. So if you are able to integrate it and get your final answer, make sure you multiply it by what? Multiply it by these two here. Okay, so let's quickly move on to a DI method. That is, let's start using the format. So let's draw a format. This is how the format goes: two columns, differentiation column, which is this, and then integration column. You already know more about this method, so I'll not talk about it much. So let's write. I said we are differentiating tangent inverse and we are integrating u to the power 3. Okay, so here we are going to differentiate this and we are going to integrate this one. So when we differentiate tangent inverse of u, we are going to get 1 over 1 plus u squared, or 1 over u squared plus 1. Addition is commutative, so anyhow you write the denominator is accepted. And when you integrate u to the power 3, we are going to get 1 over 4 u to the 4th power. And remember, the next row has to be what? Negative. That's how the DI method works. Okay, here we are not going any further. If we decide to differentiate this one, it will never give us 0, or it will never get to 0. And I don't think continue differentiating this and also integrating this will ever produce the original integral, which is u to the power 3 multiplied by tangent inverse of u, whereby we have to add it to it, and then we divide both sides with whatever we got. So the best thing here is that we are stopping. is to multiply the product of what? This and this, which can be, of course, integrated. Yeah, this and this can be, the product of this one and this one can be integrated without using this DI format or DI method again, but with other approach as well. Okay, so now that we are stopping, let's write our answers from the format. I've already told you that when you are writing your answers, the product of the diagonals, the product of the diagonals, the product of the diagonals are your what? Answers from the format. That's how this format works. So the first part of our answer is, or is going to be, tangent inverse of u multiplied by 1 over 4 u raised to the power 4. Tangent inverse of u multiplied by 1 over 4 u raised to the power 4, which is being indicated in this red, which is being indicated in this red arrow, this red arrow, this red arrow. Yeah, so when we multiply this and this is what we are going to get at the end of the day. This one is without the integral sign. So from the format, those that you write without the integral sign are your what? Answers, and those with the integral sign are what we are supposed to further work on. And that one is the product of what? This one here is the product of what? This row. The product of what? This row. You know, with the format, we stop when we can further work on the product of what? A particular row, apart from the first row, the subsequent what? Rows. So here we are going to further work on the product of what? This row. Now when you multiply this by this, that one will give you negative. This and this are positive. This is positive, this one also is positive, but because the row is negative, it's going to affect the product of what? These two. Okay, that is how come here we have the minus sign here. So when you multiply this and this, which is in blue parentheses, this row, you multiply this row, the one in blue parentheses, you just multiply it and then you integrate it. Okay, because we have not done writing our answers, or we are not done getting all of our answers from the format, but we know that we can, when we multiply this and we integrate, we will not use this format again, and we can also integrate it easily without the help of the DI method. Okay, so when you multiply this and this is what you are going to get. Okay, so this one is the first part of the answer to the integral question. This one is the first part of the answer to the integral question, and this is the second part of the answer to the integral question, but this one is not an answer yet. You could have treated this one as an answer provided this product could have result in getting the product of what? This and this, which is the original integral that we are solving. Okay, because this one didn't give that, we are going to integrate this one to what? Get another answer, which will be added to this one at the end of the day, so that at the end of the day there will be nothing left to integrate, and then we just put our two answers together and we do some computation, and then we call it a day, or we will know the answer to the original integral question. Okay, so we are going to maintain this answer, but first, you remember I said that from the original question it was 2 integral u cube u raised to the power 3 multiplied by tangent inverse of u, right? So we are going to multiply that to true. I said whatever you get, make sure you multiply it by what? The 2. Okay, so let's multiply this one by the 2. Okay, now when you multiply this one by 2, I think going to give you what? 1 over 2. And when you multiply also this one by 2, the 1 over 4 is constant. The 1 over 4 is constant, so we just bring it at the back of the integral symbol. So when you multiply this one also by 2, that is also going to give us 1 out of 2. 1 out of 2. Okay, I said this is the first part of the answer. This is we have gotten one part of the answer. We don't know the number of answers that we are going to get at the end of the day. It can be about 6, it can be 5, it can be by. All we know that we have gotten one of the answers, but not all. So the next answer that we are going to get is to integrate this one and know what we are going to get at the end of the day. And whatever we get, we just add it to this one. The answer from this one can be 3, 4, blah blah. We can get about 2 different or 4 answers. And when we are done integrating, we just add that particular answers to also this one, and then we know the exact answer to that particular integral question. So let's integrate this one. I'll omit the negative sign. I always prefer doing that way because it might confuse some of us. So I'll just always just omit the negative sign. Take this one as positive, integrate it, whatever you get, when you come back here you just replace it, and then you use the negative sign to multiply it through. And I think that one will be safer for you than if you can take this one along, no problem. If you can solve it without having any problem, no, it's okay by me. But if you think it will confuse you, just do it the way I'm doing it. I'm not saying it's gonna confuse you, it won't confuse me, but just that um some of us it might confuse us. When you take working with negative is not that easy compared to what positive. Okay, so let's solve this one. No, here I'm not doing any a b v because that one is to help you how you put your answers together. And now that we know one or two about it, why don't we forget it and then we move on. Okay, so 1 over 2 integral u raised to the power 4 divided by 1 plus u squared du. Here, you could see that this one is bigger than what? The denominator, and it's an improper fraction. And anytime you're having an improper fraction, we use long division to what? Reduce it. Okay, so here, let's use long division approach to reduce this fraction. Okay, before we integrate. So we are going to use long division. Okay, the format is long division format here. I didn't got it very well. You don't worry, at the end of the day, you get to know how it works. So okay, I said we are going to reduce the numerator. And if you want to reduce it using the long division approach, the, the denominator will be written at the back of outside here, and then the numerator will be written inside the square root sign, inside the square root sign, inside the square root sign. I'm using that one as a, something to help me, divide the fraction. Okay, so whatever the denominator will come out, and the numerator will also go inside. Okay, so when you are dividing this by this, please ignore this one. Ignore this positive one here. Just focus on this u. Just focus on this u. Now this one is u squared, and this one is what? U to the power 4. Now it's going to be u to the power 4 divided by u squared. And that will give us what? U squared. And that will give us what? U squared. So when you get your answer, write it on top here. So u squared times, when you get your answer, and after writing it on top here, you just multiply that particular answer with the whole of this. So u squared times u squared plus 1 will give us what? U to the power 4 plus u squared. Okay, don't worry about this answer appearing here. Don't worry about, I will just talk about it, so you don't worry. As I was saying, this one divided by u, just use the u alone, don't consider the one. But when you are multiplying, you just consider it as part. So u to the fourth power divided by u squared will give us what? The u squared here. Now this u squared multiplied by the whole of this will give us what? U to the fourth power plus u squared. And here we are going to subtract. So u to the fourth power minus u to the fourth power, that will give us what? 0. Okay, that will give us what? 0. You know, how will it give us 0? The coefficient of this one is 1. The coefficient of this one is what? 1. So 1 minus 1 is what? 0. And 0 multiplied by this will give us what? 0. And also, here we don't have any u squared here. All we are having is minus and then what? U squared. So minus plus u squared will give us what? That was going to give us minus u squared. Minus u squared. Okay, now minus u squared. Still, we are not done. You know, it's like still the denominator has to be so. We have to make sure the numerator is smaller than what? The denominator. So let's still reduce this. So the same way, u squared divided by u squared, that will give us what? 1. But it's not just any one. This, the whole of this is minus u squared divided by what? Positive u squared, and that will give us what? Minus 1 here. So that is the minus 1 here. This divided by this will give us what? This minus 1 here. Okay, so we are going to multiply this minus 1 by the whole of this. You know, when you get your answer, multiply it with this, the one outside here, and then before you subtract, you multiply with it, then you subtract it from the main one. Okay, so u squared plus 1 multiplied by minus 1 will give us what? That one will give us minus u squared minus 1. Minus u squared minus 1. You know, this minus sign here, it wasn't affecting anything, but it was just, I said we are subtracting, so that is the subtraction symbol for it. But when you come here, what we are going to subtract, I will just say it with my mouth, but here the negative sign here is affecting this one also, and this one's also affecting this. Okay, so it's because we multiply this one by the whole of this. So this is what we are going to get at the end of the day. So it's going to be minus u squared minus u squared. Please take note. Here you see all of them were positive because this one was positive. I should have wrote this opposite sign somewhere here, but don't worry, you'll still get it. So here is minus u squared minus u squared. You know, it has become nege, which is what? Po. Already there is another, let's see, this empty space here is minus. This empty space here is minus for this part. This minus could have, come to this part, but it was something else. So the minus here is what? This empty space here is minus. So minus u squared minus u squared. So minus become positive, and because this one is negative, this and this will be what? 0. Okay, and now minus 1 will give us what? Positive 1. So when we subtract this from this, we are going to get positive 1 at the end of the day. Now positive 1 here is smaller than this numerator. Even if we put 1 here, we are going to get it this denominator to be 2. So you can see that that one is bigger than this 1. So now we can write our fraction for it. Okay, so the answer, after using the long division approach to divide your fraction, what is left, which is smaller than the denominator, is going to be written as what? The numerator. That is, you are going to use this remainder here and this one to form a fraction by writing this one as what? Numerator, and this one as what? Denominator. Then u squared minus 1 here is also going to be added, or is going to be what integrated alongside with this and then that. So that is particular integral, which was u raised to the power 4, u raised to the power 4. After applying the long division or after reducing it, we are just going to get 1 over 2 integral this one. After reducing it, this is what we have gotten at the end of the day. That is integral u squared minus 1 plus 1 over 1 plus what u squared. Okay, so here this one we know answer to each and every one of them, so there's no need for us to split it. So we can integrate this and write the answer straightforward. Yeah, I think you can do that. This one also. And what about this? This one is something we know. Integral of 1 over 1 plus u squared is what? Tangent inverse of what? U. Tangent inverse of what? U. Okay. Okay, so when you integrate u squared, you are going to get 1 over 3 u raised to the power 3 minus, when you integrate 1, you're going to get u plus, and then from the format or from the workings, we have this place to be plus 1 over plus integral of 1 over 1 plus tangent 1 plus u squared will give us what? That one we know. When you trace substitution, this is what you are going to get. This is what you're going to get. That is tangent inverse of what? U. So this is the answer for the other part that we were supposed to further work on. Okay, so we are going to open the bracket. You're just going to multiply this one by the whole of what? This. We're going to multiply this by the whole of this. And when we do that, this one will give us 1 over 6 times u raised to the power 3 minus 1 over 2u plus 1 over 2 tangent inverse of what? U. Okay, so this is the answer for the second part. I mean, what we are supposed to further work on. But already we are having another answer there. We got two answers and we were supposed to further work on one of them. And this is the answer to that. So let's put the two answers together. Okay, so this was the first part of the answer. Now, this is the answer to the second part. Remember I said the second part you can get about 2 or 3 answers, but it doesn't matter. We can still put them together. Okay, so this was the main reason why I didn't carry the negative sign along. It could have confused some of you, not me, but it could have confused some of us. Sometimes working with negative, if you don't take care, you get the whole thing wrong. But when it's like this and you have to multiply it through, that one is easy as compared to carrying it along doing the whole lot of calculations and other stuff. So let's open the bracket. We are going to multiply this one through this. Okay, okay, good. After opening the bracket, this is what you are, inside the bracket, this was positive. Now, when you multiply by minus, you're going to get this one to be negative. This was minus in the bracket. When you open it, it become positive. This was also positive in the bracket. Now, after opening it, it has become what? Negative. Okay, so this is the answer to the integral we are solving. This is the final answer to it. But we have to go back to the x word, and going back, we know what is going to replace what? U. We know that u is equal to square root of what? X. So wherever you see u, please note, wherever you see u after the integration, you just put what? Square root of what? X there. So let's put square root of x there. Okay, so 1 over 2, that here we are having u to the power 4, so here that will give us square root of, into bracket, square root of x raised to the power 4 times tangent inverse of square root of x minus 1 over 6 into bracket square root of x raised to the power 3 plus half times square root of x minus 1 over 2 tangent inverse of square root of what? X. So this is the answer to the integral question in the x world. The answer is quite a bit lengthy, but it doesn't matter the how lengthy the answer is. We have just managed to got our answer, and that is what we are interested in. Okay, so let's simplify this one. When we leave it like this, it's too long. So let's find the LCM and then form a fraction with it so that it will be simple. Okay, almost covering the whole of this that space. So what is the LCM here? 2, 6, 2, 2. What is the LCM? The LCM is just 6. Okay, so if the LCM is 6, 2 divided by 6, then whatever you get to multiply it by this, the same thing applies to all of this one. So let's write it in the fraction form. Okay, good. Here it was square root of x raised to the power 4. It was square root of x raised to the power 4. And remember, square root of x raised to the power 4, it can be written as what? X squared. This one is same as x raised to the power half times this will going to give us what? X squared. And then, yeah, this one can also be written as x multiplied by square root of what? X multiplied by square root of x. But let's leave that one alone, and then this one we did this one because we can easily write it of this form, but this one we'll still get the square root back, so we'll just leave it as it is. Now let's write our fraction. I said with the fraction, the denominator, the LCM is what? 6. The LCM is what? 6. So when you find the LCM, that is how the fraction is going to look like. Okay, so that is the final answer to the integral, but we have to add our c back. We have to add our plus c back. We have to add our plus c back. So integral x tangent inverse of square root of x is now equal to the whole of this one plus c. The whole of this one plus c. The whole of this one plus c. The answer is quite a bit lengthy, but you don't worry. In our next video, why don't we try differentiating the whole of this to find out if we can get this one back? Would it be possible? Well, in our next video, we will be differentiating the whole of this goddamn answer. The whole of this answer just to find out if we can get this one back. It won't be all that easy, but well, we are going to try. There's no harm in trying. Okay. All right, that's it, guys. Please, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching.